So the other key question that you can ask about a sequence is, what is the long-term behavior? So when I say long-term behavior, I mean as the n becomes very, very large. In other words, if you remember from Calculus 1, perhaps, the limit as n approaches infinity of the sequence. Does it have a particular value? Does it converge? A sequence converges if there is a definite number that it is trending toward. So as an example of a convergent sequence, let's look at x sub n equals 1 over 3 to the n. So the initial term x sub 0 is equal to 1 over 3 to the 0, which is 1. X sub 1 is equal to 1 over 3 to the 1, which is 1/3. X sub 2 is equal to 1 over 3 squared, which is 1/9. X sub 3 is equal to 1 over 3 cubed, which is 1 over 27. And if you plotted this on a graph, you could do that by creating what's called a dot plot. It's important to remember you're only going to have values at discrete intervals. It's not a curve. It's just a sequence of dots. But I would have a point at 0, 1. I would have a point at 1 1/3. I would have a point at 2 1/9. Notice this is trending downward. It's going to keep getting smaller. It's going to keep approaching 0. Never actually going to touch 0. Well, that doesn't matter. You can think of this as you have 1 gallon of Kool-Aid and you invited 3 to the n people. How many gallons of Kool-Aid will... Well, by the time I've invited 81 people, people are getting very little Kool-Aid and they're probably not happy. By the time I've invited 1,000,000 people, technically they might be getting a little bit of Kool-Aid, but there's so little Kool-Aid that they're not happy. The limit as n approaches infinity of x sub n would be equal to 0. Because this sequence is definitely trending. It's getting closer and closer and closer to 0, even though it never actually takes on the value 0. Now, it is possible you could have a sequence that converged where it did take the value. For instance, another example of a convergent sequence would be, look at y sub n is equal to pi. And it's always equal to pi. So the initial value is equal to pi, the next value is equal to pi, y sub 2 is equal to pi, y sub 3 is equal to pi. The plot's pretty boring. It's a constant sequence, always at pi, no matter which time step you're on. Well, the limit as n approaches infinity of y sub n will just be equal to pi. So those are two examples of convergent sequences, and let's look at one more. So the example we're going to look at now is, let's look at z sub n is equal to 2 to the n over 3 to the n. So I can rewrite this as 2/3 raised to the n. This is a similar pattern to what we saw before. We're going to start out with z sub 0 is equal to 2/3 to the 0, which is equal to 1. Z sub 1 is equal to 2/3 to the 1, which is equal to 2/3, and we just keep going. So notice every time we do this, we multiply by 2/3. So you could think about this as like having a square, and on the first piece you have the whole square, and then you have 2/3 of the square, and then you have 2/3 of that. So it's getting smaller and smaller. This is an example of exponential decay, and when you see that, you're heading towards 0. This piece of the square that you have left, as you keep taking 2/3 of it, would be eventually trending towards 0.